This is UMLZ03. In the previous video, we brought up two new concepts. We talked about ASCII character encodings, and we said that basically the ORD function accepts a character and returns an integer representing a character encoding, right? Like an integer that represents that character, and it's called ASCII, right? So lowercase e has a particular character encoding, like 92 or something, and then the $ has another character encoding, like 112 or something like that. But what we're going to do is we're going to review some concepts. So essentially, we have to remember that JSON objects are string representations of dictionaries. So the JSON module provides a loads function, which accepts a string and returns a dictionary. And the JSON module also provides a dumps function, which does the opposite. It accepts a Python object and returns a string. So then we could say import JSON, and then we could say JSON.loads of x and JSON.dumps of x. We could also just select to import those two particular functions. So we could say from JSON, import loads and dumps, and then we could just say loads of x and dumps of x in our program. We could also go ahead and import those two functions as different names. So you could say from JSON, import loads as L, dumps as D, and then you could just say L of X and D of X. And then you could also import a module under a different name. So import JSON as W, and then you call W.loads of X and W.dumps of X. That's a little bit of a review of the JSON module in particular, and also the options that you have for importing functions within a module. And then we also talked about frozen dictionaries, which represent a collection of key value pairs that is immutable. You can establish key value pairs when the object is first created, but no longer after that, right? You can't modify it after you initialize it. No adding or removing key value pairs and no changing the values associated with existing keys. You can implement a string representation of a frozen dictionary, right? Or that's called the str magic method. We've seen examples of that in previous videos. You can make a frozen dictionary object callable by providing a call magic method. You can determine the number of key value pairs in a frozen dictionary by implementing an len magic method. And then the callable of x function returns true if x is callable, right? So does your class implement call? Well, if it does, then callable of x will be true. Otherwise, callable of x will be false, right? So hopefully that's clear to you. And then remember, the keyword module provides an iskeyword function to determine if a Python word is a keyword, like def or break or continue or for. And then type of x will determine the data type of x. Hex of x accepts an integer and returns a hexadecimal representation of x. So you have to remember that hexadecimal numbers are base 16. So you don't just have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, right? So that's listed here. And then ord of x accepts a character and returns the ASCII character encoding, as we saw in the previous video. CHR of x is the opposite. So that will accept like a number, like a character encoding, and return the character whose code was the number you specified in the input of the function. But both of them are one-to-one mappings. You'd never have two characters mapping to the same encoding, and you'd never have two encodings mapping to the same character. It's one-to-one. And then we talked about this zip, and we said that zip will basically line up elements corresponding, right? So if you have two tuples here, like A equals the string potato and the number 15, and B equals the Boolean true and the Boolean false, then if you have tuple of zip of A, B, then you would have a tuple, right? Because we said it's a tuple, but then each of the elements are tuples always with zip. The zip yields tuples. So the things in the tuple are tuples since it's zip, right? So you say potato and true, and then 15 and false. So what we do is we have basically tuple unpacking and function reference variables. So we're going to say fp equals hex print. Okay, so whenever we say f of x, we're talking about the hexadecimal representation of x. Whenever we say p of x, that means that we just want to print x. So we're going to review hex numbers, right? So we could say p of f of 2. So we're going to say print the hexadecimal representation of 2, and we just get 0x2 because we said the hexadecimal numbers always start with 0x. P of f of 18, well, that would be 0x12 because we have 1 times 16 plus 2 times 1, right? And then P of f of 48, well, you have 3 16s there, but then like 0 1s, right? There wouldn't be any remainder, so that's why you just get 3 0. And then 5D for exec of P of f of 93, because 93 is 16 times 5, that's why you see the 5 here, plus 1 times 13, because we said that the D corresponds to a 13. So 80 plus 13 is 93. And then you could say P of f of a val of the string 225, because we said a val accepts a string and returns like the literal representation of whatever is in the double quote. So it'd be basically P of f of 225. And so 225 as a hex would be E1, right? Because it's 16 times 14, which is 224, plus 1 times 1, which is 1. And then p of int of 0x61, so you can go in the opposite direction. So what if you have a hexadecimal number 61? Well, that would be 16 times 6 plus 1 times 1, which is why we get 97. And then you could also do float of a hex. So p exec of p of float of 0xA8. Remember, p is just printing. So you get 16 times 10 plus 1 times 8, which is 168.0 because it's a float. And then you could say p of string of 0x5b concatenated with apples. So you can concatenate two strings together, and 5 times 16 plus 11 times 1 is 91. So that's why it says 91 apples. And then we talked about ASCII, right? So you could say YZ, and then you have two lambda functions here. It's tuple unpacking and lambda functions. So Y is basically ord of S, and Z would be CHR of S. So these are inverses. One accepts a character and gives you a number. The other accepts a number and gives you a character. But if you do P of Y of E, so that will basically tell us ord of E. So what is the character encoding for E? And you get 101. And then what's ord of C? Well, that would be 99. And then you can go, and you can also do the opposite. So P of Z of 123. So what's the character with the encoding 123? Well, that would be, I guess, the opening curly brace, right? And then what's the character encoding of, what's the character associated with the encoding 100? Well, that would be D, right? It kind of fits between E and C, right? Between 99 and 101. So it's pretty chronological. Everything is ordered. Everything should make sense, right? And then you could also have the inverse cancel out. So what if you say P of Y of Z of 98? So ord and CHR are inverse functions. They cancel each other out, and then you would just get the 98. And then P of Z of Y of $, you would just get the $. So hopefully that's clear to you. And then we can go ahead and review the zip function. So we could basically say, we can review the zip. So we can have a list and a tuple. So what we've been, in the previous video, we basically were just zipping two tuples together, but you could also zip a list with a tuple, right? They don't have to be the exact same data structure. So here T is a list, but they do have to presumably have the same number of elements in them. So here T is a list with 3 elements in it, and U is a tuple with 3 elements in it. So you say print frozen set of zip of UT. And then basically that would say frozen set of, and then you would basically have hot dog with carrots, and then popcorn with lettuce, and candy with potato. Because remember, we said frozen sets are not ordered, okay? So you cannot assume that the tuples will come out in a particular order. They are matched together, right? So at index position 0, you have candy and then potato, and that's why you form this tuple with candy and potato. At index position 2, you have hot dog and carrots, and that's why you basically lump those together into this tuple. That's the working of the zip function, okay? And then you could also say whether equals, and then you have, I guess, 9 integers here, so 52, 54, 61, 66, 66, 68, 64, 62, 60. And then index positions equals tuple of range of length of whether. Okay, so that would basically be a tuple with 0, 1, 2, 3, 4, 5, 6, 7, 8. And then you could say try asserting that list of enumerate of whether is equal to list of zip of index positions with whether. We saw this in the previous video, but these would return the same thing because we said enumerate is kind of like zipping the index positions with the elements at those index positions. And here we can see that there's no issue with that assertion. There's no assertion error. And that's why it says, yep, they're equal, all right. So list of enumerate of whether is equal to list of zip of index positions with whether, where index positions is just, you know, range of length of whether, tuple of range of length of whether. So hopefully that's clear to you. And then remember, the finally block prints regardless. So that's why we say the finally block prints regardless here. So even if there had been an assertion error, you would still print what's in the finally block. So hopefully that's clear to you. And we just briefly reviewed some of the things that we were talking about in lessons 68 and 69. What I want to do in this video is talk about pass by value. So basically how Python works is it basically passes elements by value. So I have a little bit of a description here of that. So that means that it makes a copy of a variable and uses that copy within the context of the static method. So unexpected behavior can occur with that. So let's try doing something. So we have a very simple function here on 83 and 84. We say define add 1 of w, and then it says w plus equals 1. So presumably this should accept a variable and add 1 to it. So we're going to say add 1 of tornado colon equals 42. So we're using the walrus operator to do two things at the same time. First, we're saying that tornado is assigned to 42, and we're passing that tornado, that 42 value, into the add 1 function. And then we're going to print, did we add 1 to 42? And then if we print the value of the tornado again, it still says 42. And that's kind of weird because we were expecting 42 to increment to 43. That kind of seems like what it should do, you know, on line 84. The problem is that the 42 is just passed in as a copy. Okay, so basically Python passes information by value. So that 42 comes in locally and the 42 becomes a 43, but then you don't take that 43 with you, right? So the 42 here assigned to tornado is sort of unchanged, and that's called pass by value. And there are mixed opinions about it. I personally think that it's a little counterintuitive. It's a little hard to understand. The good news is that there's three solutions around it. So there's three things that you can do to prevent this situation where we want to add 1 to a variable, but it doesn't seem like it does that successfully. This is called pass by value, and there's three ways around it. The first one is to use an instance variable and update it as it belongs to a particular object. So what I did is I have a class called solution here, and there's a very simple constructor which accepts one input, and it assigns a myNumber instance variable to whatever input is passed into the constructor. And then it says define solution1, and then print let's successfully add 1 using an instance variable. And then it says self.myNumber plus equals 1. Okay, and then so what we can do is let's look at the code here. So basically what this solution1 does is it basically takes the add 1 method, but it makes it into like an instance method form, right? So now this is an instance method, and basically it will increment the value of the instance variable. And let's see if that's more successful at incrementing a particular value of a variable. So what we're going to do is we're going to start with an initial value of 63. So it says print starting with an initial value of string of initial value colon equals 63. So again, it assigns initial value to 63, and then it just goes ahead and does this concatenation. So then we're going to say a equals solution of initial value, because we said the constructor for the solution class accepts one input, and then we're going to call a.solution1, and here a.solution1 will increment the value of the instance variable by 1. So then if we try to print a.myNumber, if we try to print the new value of the instance variable, it was successfully incremented from 63 to 64. So this is one solution that you have to the pass by value phenomenon, where it seemed like the add 1 method that we talked about a few minutes ago wasn't doing what it was supposed to be doing. Basically, one solution is to use an instance method and to keep up with an instance of a class, like an object, and to increment the instance variable for that object by 1. It seems to work a lot better, and that's why 63 is incremented to 64. You just say a equals solution of initial value, a.solution1, print a.myNumber, and then a.myNumber is no longer 63, it's 64. So that's one solution that you have. You could also go ahead and just return a new value. So you could have a static method. It doesn't have to even belong to a class, but you could say define solution2 of s, and then you could say let's successfully add 1 by returning a value rather than using void. So you can see like this solution1 method and this add 1 method that we talked about a few minutes ago are void methods, right? They don't really return anything. But in this solution2 method, we're going to return a new value. So we're going to accept an s, and we're going to increment s by 1, and then we're going to return the new value of s. So then what we do down here is we say p of solution.solution2 of initial value. So what does this do? So it's going to print the result of the solution2 method, which belongs to the solution class, when we pass in the initial value. So as a result of doing that, you can see that the 63 is incremented to 64 because solution2 returns a new value rather than simply having some void operation that tries to increment something. But this is another technique that you have at your fingertips, is to return a value rather than simply doing some void operation. But here, this is another way that you could increment 63 to be 64 instead. The third option that you have available to you is to use a one-dimensional list, or to use a list with one element. So we have another static method here. So static method is just a standalone method. It doesn't even have to belong to a class necessarily, but you say define solution3 of s, and you say print let's successfully add 1 by using a list with just one element, and we're going to say s of 0 plus equals 1. So presumably s must be a list that holds at least one element. Okay, here we're just paying attention to the first element in the list, but it just says s of 0 plus equals 1. It's a void method. There's no instance variables or anything, but it's just using a list rather than some standalone integer. So now what we can do is we can try that out. So we can say my list equals, and then it's going to be a list with one element in it. And that element is going to be the 63. It's going to be the initial value. And then we could say solution.solution3 of my list. So basically that's going to increment that 63 to a 64, because we said the solution 3 accepts a list and increments the first element within it. And here there's only one element, so it's going to increment it. And then you're going to say print my list of 0. And then here, that's why we get these two lines. So here it says, let's successfully add 1 by using an instance variable, and indeed we get the 64. So these are 3 solutions that you have available to you. Either use an instance variable and update it as it belongs to a particular object, make your method return a new value rather than making a void method, or use a one-dimensional array. So hopefully those give you 3 different techniques that you have in order to combat the pass by value phenomenon, which was giving us some unexpected results a little earlier in this video. The last thing I want to do with the last 4.5 minutes is talk a little bit more about sets and dictionaries. So we have another function here. And so what we're going to do is we're going to say my set1 equals, and then we're going to have 2 sets here. So we have 2, 9, cancel up island, 2, 9, true, false. Remember, sets can only have unique elements. If there are duplicates, they will automatically be removed from the set until there's only one element uniquely, right? And but the point is basically what we didn't say earlier is that you can also have, instead of saying my set1 dot intersection of my set2, you can just say my set1 and this ampersand sign my set2. So this is just a more compact way of determining the intersection of 2 sets. What is the collection of elements that belongs to both of the sets? And here you just get 9 and 2. And remember, sets are unordered. So it might be 2, 9, it might be 9, 2, but it's still the same. Sets are unordered. But the point is that you can just use this ampersand sign rather than saying my set1 dot intersection of my set2. It's just a little bit more compact. And then same thing for union. So instead of writing my set1 dot union of my set2, you can just have my set1 and then this vertical bar and then my set2. It's just a little bit more compact. And then you would get all the elements that belong to at least one of the 2 sets. You would get false, true, 2, cantaloupe, 9, island, right? You get everything that is in at least one of these 2 sets. And then I think we also talked about a difference method. So what if we want all the elements that belong to my set1 but don't belong to my set2? So here you could say either my set1 dot difference of my set2, all the elements that are in my set1 that are not in my set2, or a little bit more compactly, you could say my set1 minus my set2, and that would just give you cancel up an island, right? Because the 2 and 9 appeared in my set2. And since we're doing this difference operation, the 2 and 9 are sort of going to be subtracted. They're going to be removed. And then my set1 minus my set2 would just have these 2 unique elements that were in my set1, but not in my set2. But the point is that you can just have this more compact syntax rather than writing dot intersection or dot union or dot difference. So hopefully that's clear to you. The last thing I want to talk about in this video is a little bit more about dictionaries. So we know that dictionaries are a set of key value pairs, but one of the things you have to remember is that the keys in a dictionary cannot be mutable. So mutable means that an object can be modified, it can be changed. And that means that lists, dictionaries, and sets cannot be keys to a dictionary, okay? Use a tuple, frozen set, or frozen dictionary instead. So what we're going to do is we're going to create a my dictionary, and it actually just has 2 key value pairs in it. So one of them maps this tuple to this list, right? It maps the tuple 5, 3 to the list 52, 39. And then the second key value pair maps the frozen set with the 3 elements 9, 2, 1 to a dictionary within the dictionary, right? 9 to 90, 2 to 20, and 1 to 10. It's okay to have a dictionary be a value of a dictionary, right? But tuples are better than lists only because tuples can be keys in a dictionary. Lists cannot be keys in a dictionary. So hopefully you can take that away with you. Dictionaries cannot be keys in a dictionary. Try using a frozen dictionary instead. That's what we implemented a few lessons ago. And then sets cannot be keys in a dictionary. Try using a frozen set instead, which is what we talked about in lesson 57. So then what we're going to do is we're going to say P of my dictionary of 5, 3, right? So you can just basically use these square brackets and you feed in a key and you get the value out. So you just get the list 52, 39, but then you could go ahead and change it. So you can say my dictionary of 5, 3 equals F of 150. And if you remember from earlier in the video, F is just the hex function. It's a function reference variable for hex. So what's hex of 150? Will be 9 times 16 plus 6 times 1. So that would be, that matches up with the 96. This is a hexadecimal representation of 150. And then you could have also said my dictionary.update of frozen set 921 with sup. And then if you could say my dictionary.get of frozen set of 921, what is the new value occupying that key? Well, it would just go ahead and say sup. And then you could have a string representation of the dictionary. So hopefully that was interesting from UMOSO 3. Thanks for watching, and please subscribe.